In this chapter, students will explore where the formulas for area of two-dimensional shapes come from. Students will learn about surface area and will extend their knowledge of volume to fractional edge lengths. Students have had some previous experiences with two- and three-dimensional shapes that will serve as a foundation for the concepts and skills taught in this chapter. In third grade, students first explored area by tiling a region without any gaps or overlaps. This concept prepares students to use the formula to calculate the area of a rectangle using length times width. For example, students found the area of this rectangle to be 9 units by laying out tiles and counting each tile. In 4th and 5th grade, students use this prior knowledge as they model multiplication and division using area models and arrays as seen here. In 5th grade, students learned about volume. Volume is the amount of space a three-dimensional object occupies. Students learned that volume is equal to the length times the width times the height, or the area of the base times the height. Before discussing the skills taught in this chapter, let's discuss the conventions of variables and the unit labels. When working with variables that represent one-dimensional attributes, they are most commonly represented as lowercase letters in italics. For example, length, width, and height. When working with variables that represent multi-dimensional attributes, those variables are commonly represented as uppercase letters in italics. For example, area, area of the base, and volume. When measurements are abbreviated, metric units are abbreviated without a period, while standard units are often abbreviated with a period. Finally, when discussing volume and area, this unit should be verbalized as square centimeters, and this unit should be verbalized as cubic centimeters. This will help avoid confusion. This chapter invites students to explore where the formulas for the area of two-dimensional shapes come from. Students will use their understanding of area to calculate the area of parallelograms, triangles, and trapezoids in that order. Students will discover that the area of rectangles, parallelograms, triangles, and trapezoids are all related. For example, students will find that the parallelogram can be decomposed into a rectangle. Therefore, the formula for the area of a parallelogram is the same as the formula for the area of the rectangle. Area is base times height. Previously, students viewed the dimensions of a rectangle as length and width. In this chapter, students will use base and height to describe the dimensions. The labels of base and height can be generalized to all parallelograms and is helpful when students are developing and discovering the area formulas for trapezoids and triangles. The dimension labels of base and height are also used when labeling three-dimensional objects and is useful when finding the volume of the objects. Here is a rectangular prism. The volume for this prism is the area of the base times the height. After learning about area, students move on to volume and surface area. Just as many students confuse area and perimeter, students also struggle differentiating surface area from volume. Volume is what is inside a three-dimensional shape, and surface area is concerned only with the outer surface of a shape. Volume uses cubic units, and surface area is square units. Students will focus on finding surface area of right rectangular prisms by creating nets of the figure. A net is the shape that is formed by unfolding the outer surface of a three-dimensional figure. For example, here is the net of a cereal box with the length as 7 1/2 inches, the width as 3 inches, and the height as 10 inches. The area of each face is calculated, then added together for a total surface area of 255 square inches. In this chapter, students will explore where the formulas for the area of two-dimensional shapes come from. Students will learn about surface area and will extend their knowledge of volume to fractional edge lengths. Again, it is easy to throw out the formula and request students to memorize and spew it back out. However, this does not promote understanding, and it keeps math a mystery. Students should be encouraged to compose or decompose shapes using reasonings to calculate the area in each problem.